Today we're going to be talking about the SN1 and E1 reactions. Let's start with SN1. This reaction occurs between an alkyl halide and a nucleophile. It's important for the alkyl halide to be tertiary because this mechanism involves a carbocation intermediate, and a tertiary alkyl halide allows the most stable carbocation to form. Here we have our leaving group, bromine. The first step of this reaction is when the leaving group leaves. After bromine leaves, a tertiary carbocation is formed. The next step involves the nucleophile, which we have here as methanol, coming in to attack. The lone pairs on oxygen attack the carbocation. Now we have an oxygen with a formal charge. Another methanol molecule will now come in and take a hydrogen off of the oxygen with a formal positive charge. Now we get our product in which the nucleophile has replaced the leaving group. It's also important to note that this is the slow step, as the carbocation is formed in this step. This step is fast. Because this is the slower step, this is the rate determining step. The product in this problem does not have a chiral center, so we don't need to worry about stereochemistry. But in SN1 reactions, a racemic mixture of products is formed because of the carbocation intermediate.
Now we will be talking about the E1 reaction. In this reaction, we need a tertiary alkyl halide, which has a leaving group, bromine, and a nucleophile. Like the SN1 reaction, the E1 reaction requires a tertiary alkyl halide because it also forms a carbocation intermediate, and you want to form the most stable carbocation intermediate. In the first step of the reaction, the leaving group, bromine, leaves. This forms a tertiary carbocation. It is important to identify the alpha and beta carbons. The alpha carbon is the carbon attached, in this case, to the leaving group, while the beta carbons are the carbons attached to the alpha carbon. The carbocation forms on the alpha carbon. Now, the nucleophile will come in and attack the hydrogen on the beta carbon. When the nucleophile attacks the hydrogen on the beta carbon, the bond between the hydrogen and the beta carbon breaks, and the electrons form an alkene. Now we have our product, which is an alkene. Like the SN1 reaction, the formation of the carbocation is the slower step, so it is the rate determining step, while the formation of the alkene is the faster step. Now let's look at the similarities and differences between the SN1 and E1 reactions. Both the SN1 and E1 reactions require a poor or moderate nucleophile, but a base can also be used for the E1 reaction. Both reactions require a good leaving group. For this reaction, the better leaving group is the halogen farther down on the table. For example, iodine is better than fluorine. Both reactions require a tertiary substrate, or they can sometimes work with a secondary substrate. This is because, as previously discussed, they both form a carbocation intermediate, and we want to form the most stable carbocation. Both reactions must be in a polar protic solvent in order to work.